Okay, this video is about, I'm going to do number 51 from section 4.4 from the Barnett Trig book. The name of the book officially is Analytic Trigonometry with Applications. It's the 11th edition. Okay, so this involves using half-angle identities. They gave us this information. They said that tangent of angle X is equal to negative square root of 8. And that angle X lies between 90 degrees and 180 degrees. We have to find the exact values of the sine of X over 2 and the cosine of X over 2. So we're going to use the half-angle identities. And since they asked for exact values, that means that we have to write it with the square root in it, not in decimal form. So that's what we have to give them. When you use the half-angle identity, so here is the formula sheet right here. So when you use the half-angle identities, this is a copy so you can hardly see it, but it says the sine is determined by the quadrant in which X over 2 lies. So we have to figure out what quadrant that would be in. They gave us this information about X. So if we take this equation and we divide X by 2, we divide every part of this inequality by 2, we get 45 degrees is less than X over 2 is less than 90 degrees. So here's our unit circle. We know that this is 90 degrees and this is 180 degrees, and so this quadrant 2 is where X lies. That's what they gave us. And then we did this little division and we found that 45 degrees and 90 degrees, here's 45 degrees. This is in X over 2 lies in quadrant 1. So that's important because we're going to have to choose the correct sign. All right, how do you even begin this process? Well, let's write down what the formula is for the sine of the square root, the sine of X over 2. We're going to use this. I'm getting this off the formula sheet I just had a second ago. It says that the sine of X over 2 is equal to plus or minus the square root of 1 minus the cosine of X over 2. All right, but we already talked about what angle X over 2 lies in, what quadrant X over 2 lies in, and we know it lies in quadrant 1, so I'm just going to get rid of the negative sign. I know it's going to be positive. The cosine of X over 2 is equal to plus or minus the square root of 1 plus the cosine of X all over 2. But I already said, hey, where does X over 2 lie? It lies in quadrant 1, so I get rid of the negative right away. I know this is going to be positive. We took care of that. Now, in order to plug some information into this formula and calculate it, we have to figure out what the cosine of X is. And that's where this comes into play. They gave us this information. And they said that X, they told us that it lied between 90 and 180. So we know X is in quadrant 2. So draw yourself a triangle, a reference angle up against the x-axis in quadrant 2. If we know that, and this is angle X, the tangent is negative square root of 8. The tangent is defined to be the sine over the cosine. So I'm going to think of it in those terms, and I'm going to write negative square root of 8 as a fraction. And so I'm going to say the sine is square root of 8 over the cosine is 1. So we know that's opposite over adjacent. You can also think of tangent as opposite over adjacent. But the value is negative. And so I know since it's in quadrant 2, the sine is positive and the cosine is negative. So that's where the negative goes for the tangent. I'm going to use the Pythagorean Theorem to come up with the hypotenuse here. So let's see, negative 1 squared plus the square root of 8 squared is equal to c squared. So negative 1 times negative 1 is 1. The square root of 8 squared is just 8. This is c squared. 9 is c squared. So the square root of both sides, c is going to equal to the square root of 9, or 3. The hypotenuse is never negative. So that is all the information I need to know about angle X. If I need to know what the cosine of angle X is, I know cosine is adjacent over hypotenuse. So the cosine is going to be negative 1 over 3. So that's what that is. Let's see here. What do I need to do now? The cosine of x is negative 1 over 3. So now I'm going to plug this in this formula. So if I'm going to go calculate the sine of x over 2, that's equal to, I already know it's positive, the square root of 1 minus the cosine of x is negative 1/3 all over 2. So this is equal to the square root of 1 minus minus is a plus 1/3 all over 2. If I have to add 1 plus 1/3, I'm going to think of it as 1 over 1 plus 1/3. I'm going to common denominator of 3. This is 3 over 3 plus 1/3. This is 4/3. That's what 1 plus 1/3 is. This is equal to the square root of 4/3 over 2. So I had a mistake on the key. So I can think of the 2 as 2 over 1. This is a keep, change, flip. This is the square root of 4 over 3 times 1 over 2. This is going to be the square root of 2 over 3. Now, if you rationalize the denominator, this would be times the square root of 3 times the square root of 3. This could also be thought of as, I've run out of room, so I'm going to write it over here. The square root of 2 times the square root of 3 is the square root of 6 over 3. This is an acceptable answer, and this is an acceptable answer for the sine of x over 2. All right, let's go over here and let's calculate the cosine of x over 2 is equal to, we already know it's in quadrant 1, so it's going to be positive, the square root of 1 plus cosine of x is negative 1/3 over 2. So this is equal to the square root of 1 minus 1/3 over 2. 1 minus 1/3 is 2/3. This is equal to the square root of 2 over 3 times 1 over 2. It's another keep, change, flip. This is the square root of 1 over 3. I've run out of room again. So the square root of 1 is 1 over the square root of 3. This is an acceptable answer. Or if you rationalized it, you'd say times the square root of 3 over the square root of 3. That would equal to the square root of 3 over 3. This is another acceptable answer for the cosine of x over 2.